Question number 1. Find the least value of the following functions. So we know this is a quadratic equation, then it has a minimum. So we need to find the minimum. In here we don't need to find, we want to decide whether it is a minimum or maximum. Already the sum is given. Sum in the sum it clearly say that it has a minimum. But find that minimum. So what shall we do? First of all, at the minimum point, we know that dy by dx is 0. At minimum, dy by dx equal 0. Or since this is fx, f dash x equal 0, we'll find f dash x, that is 2x minus 12, make it equal to 0. So x equal 6. Now we have the coordinate x value is 6. What is the y value? So we'll substitute the function now. f6, not f dash 6, f6 is 6 square minus 12 times 6 plus 8. So this is 36. And this is 36. 12 times 6 is 72 plus 8. So this answer is going to be minus 28. So coordinate of the least value is this one. Coordinate of least point, not value, point is 6 minus 2. Question part B. We'll find f dash x, that is 2x minus 8, at minimum f dash x equal 0. Gradient is 0 because minimum is a stationary point. The function is neither increasing nor decreasing. So what is f dash x? This is 2x minus 8. So 2x minus 8 equals 0. 2x equal 8, x equal 4. So when x equal 4, that is going to be 4 square minus 8, 4 minus 1. So this is 16, this is 32 minus 1. This is going to be minus 17. So the y value is minus 17. Let's see. F dash x is 10x plus 2. At minimum, f dash x equals 0. 10x, hence 10x plus 2 equals 0, x equal minus 1 over 5. Now we want to find this one. So we know the x value now. In this point, x value minus 1 over 5. F minus 1 over 5 is 5 times minus 1 over 5 square plus 2 times minus 1 over 5. 5, this is 25, and this is 2, 5. So I'll multiply by 5 to make denominator same. This is going to be 5 minus 10 over 25. So 5 over 25. So this is my 1 over 5. So the point is going to be so this is minus 1 over 5. This is also minus 1 over 5. So we want to find the least value. Least value is y value basically. So least value is minus 1 over 5. Not this 1 over 5. Y value. So question number A. We had f6 equal minus 28. So hence least value is minus 28. Question number B. Least value is minus 17. Question number 2. Find the greatest value of the following points. So greatest value, we know greatest means maximum. For a given x, what is the maximum value? It may be here or above or below the x-axis. If dash x equal minus 10x, at maximum it is a stationary point and gradient has to be 0. So if dash x equals 0, it means minus 10x equal 0, x equal 0. So if 0 is 10 minus 0 square, which is 10 minus 0, 10. Then the maximum is here. So maximum value is 10. So this is 0, 10. The greatest value fx is 10. If dash x is 2 minus 2x. At maximum, if dash x equals 0. So 2 minus 2x equal 0. X equal 1. Now f dash 1. Now I found the x value of this stationary point, that is 1. Now f dash 1 is 3 plus 2 times. Now I want to find the y value. I know the curve now. Fx equal 3 plus 2x minus x square. Now this is 2 1 minus 1 square. So 3 plus 2 minus 1. So 5 minus 1, 4. So this value is going to be, so this is not f dash, this is f 4. Hence the greatest value of fx is 4. Part C is fx equal 6 plus x 1 minus x. 6 times 1 6, 6 times x 6 x plus times minus minus x times 1 x plus times plus x times x square plus times minus minus. So 6 minus 5x minus x square. This is fx. Then f dash x is minus 5 minus 2x. Now at maximum or greatest, f dash x equals 0. Hence minus 5 minus 2x equal 0 because f dash x is mean this one. So 2x equal minus 5, x equal minus 5 over 2. 6 minus 5 over 2, 1 minus minus 5 over 2. 6 minus 5 over 2, 1 plus 5 over 2. So this is going to be 12 minus 5, 7 over 2. This is also 7 over 2. It means 49 over 7 times 2 or 12 1 over half. So greatest value is 12 and half. Number 3, find the coordinate of the point where the gradient is 0 on the curve with the given equation. Establish whether these points are local maximum, local minimum points or point of inflection. So now we need to find, first of all we'll find the stationary point. For that, at the stationary point, dy by dx 0. So first of all find dy by dx. So this is 8x plus 6. Now we'll make it to 0 to find the stationary point. So at stationary point, dy over dx equals 0. Hence 8x plus 6 equals 0. X equal minus 3 over 4. Now we have a point. In this point we have x coordinate minus 3 over 4. Now I need y. So y when x equal minus 3 over 4. When x equal minus 3 of y equal 4 minus 3 over 4 square plus 6 times minus 3 over 4. 4 times 9 over 16 plus minus 18 over 4. So this is cancelled out 4. 9 minus 18 over 4 minus 9 over 4. So the point is now 9 over 4. Now is this point? What kind of point is this one? Maximum, minimum or point of inflection. So assume that this point is somewhere here this is the point, or it can be down, so I'll assume it is here. This x value is minus 3 over 4. So at x equal 3 over 4, now we have uh, two places. X less than minus 3 over 4 area, this is x equal minus 3 over 4, and this area is x greater than um, okay, minus 3 over 4 greater than x. So this is x equal minus 3 over 4, this area greater than x, and then x greater less than minus 3 over 4. Now we'll check dy by dx. dy by dx value. So what is dy by dx? 8x plus 6. dy by dx equal 8x plus 6. Now I want to find in this area less than minus 3 over 4. Can you tell me any number less than 3 minus 3 over 4? Okay, minus 10 is minus less than 3 over 4. Right, so when you look at dy by dx at x equal minus 10, so 8 times minus 10 plus 6, this value is negative. I don't need to look at, this is minus 80, so this value is negative, and this is 0. Now at greater than minus 3 over 4, let's say 10, so dy over dx when x equal 10. So this is going to be 8 times 10 plus 6. That value is positive. Right? So this gradient, you know what is gradient, right? So this is positive gradient, this is negative gradient. So this gradient, here negative, here it is 0, here it is positive. So what is this one? So it is a minimum. So when x equal minus 3 over 3, it is a minimum. When x value is minus 3 over 3, what is the y value? Y value is define minus 9 over 4. Actually, we know the value, so it should be here. So this is minus 9 over 4. So this is minimum. So we can find, right, minus 3 over 4 minus 9 over 4 is a minimum. This is the first method. How do you find with the second method? The second derivative. Right. So first derivative is dy over dx is 8x plus 6. Differentiate one more time. D square y over dx square equal 8. So what do you know that if d square y over dx square greater than 0, then actually let me do like this. So you found out d square bar is 8. Now at which point? D square over dx square at when x equal minus 3 over 4. This is the point. And still there are no x, so answer is 8. It doesn't matter, 8 greater than 0. Hence, if it is greater than 0, what is this point? Hence, the point is a minimum point as d square y over dx square greater than 0. The second one is y equal 9 plus x minus x square. Now we'll find the stationary point. So first of all, dy over dx differentiation. X is 1, this is 2. So at stationary point, dy over dx equals 0. Hence 1 minus 2x equals 0. Hence x equal what? Half. Now in this point, x is half. What is y? So when x equal half, y equal, we substitute here 9 plus half a plus half a square. 9 plus half a minus 1 over 4. So this is will become 9 plus 3 over 4. So this is half a minus actually. So when you have a half a bread and when you take quarter, remaining is quarter. So 9 1 over 4. Now what is this point? 9 1 over 4. Now this point is maximum or minimum. So this point is on somewhere x is half here. Is this point minimum or maximum? We know this is a quadratic equation and a value is negative. We know this is going to be a maximum. Having this knowledge, but still we have to work and show. So shall we go with the second method? Yes. So dy over dx is 1 minus 2x. Then d square y over dx is minus 2. Hence at x equal half, dy square dx square at when x equal half, still minus 2. There are no value to submit, which is less than 0. Hence, the stationary point is a maximum. We discuss the rule now. If double derivative is negative, then that point is a minimum. So this is going to be a minimum point. Sorry, maximum. Like this. So this is maximum. Dy over dx is 3x squared minus 2x minus 1 and at a stationary point dy by dx equal 0. Hence 3x square minus 2x minus 1 equal 0. We can factorize this one and x minus 1 equals 0. So 3x plus 1 equals 0 or x minus 1 equals 0. X equal minus 1 over 3 or x equal 1. Now we have two stationary points. Let's find the relevant y value. So this is minus 1 over 3 and this is 1. First of all, find what is the y value. When you substitute x equal minus 1 to this one, so y equal minus 1 power third minus 1 over third square minus 1 over third plus 1. And when you calculate this one, you will get answer 15 over 27. So this is 15 over 27. And when x equal 1, y equal 1 cube 1 square minus 1 plus 1. This is cancel out. 1 minus 1. So this is going to be 0. Cancel out. This is 0. So 1, 0, 1 point. So it can be minimum, both point, or maximum, point inflection. Just for one value, we use the second system. Okay. Okay, we'll take x equal minus 1 over 3. So I break the number line. So this is minus 1 over 3 and this is left and this is right. So on dy by dx equals 0. And how about this side? Minus 1 over 3. So think about a value less than this. Minus 1 over 3. Okay, 0 is here actually. Minus 10. When you put minus 10 here, this is become positive. Okay, minus 1000. So when you put minus 1000, minus 1000 square, this is become positive. I'm talking about the gradient. And this is going to be minus 2000. So this is going to be positive. So dy by dx here is positive value in here. So we put minus 1000. What will happen if we put 1000 to this side? And the other value is 1 and greater than 1. So there are two values. So the next one has to be minus 1 over 3 and in between 1. So in that case, this is going to be dy by dx is, let's say 0, 0 is here. When you put 0, this is 0, this is 0, negative. So this is negative. It means gradient like this. This is 0 and here. Now in here again dy by dx equal 0. Right? And after 1, what will happen? If you put 10,000. So when you put 10,000, I think I did the wrong drawing. Is this gradient positive? So gradient positive, which side? This side or this side? It has to be this side, then this one, and then the gradient negative, and then gradient is 0. So this point is a maximum point. And then let's say 1000 x value. Let's say after 1000 square, this is going to be positive. Dy by dx is positive. So it's going to be like this. So it is a minimum. So this is a maximum. Minus 1 over 3 is a maximum. And this is a minimum. But we want to show properly. So we'll go with the double derivative. So with the second derivative. So dy by dx equal 3x square minus 2x minus 1 d square y over dx square equal 6x minus 2. Now at x equal minus 1 over 3, what is the value of dy over dx square? That is 6 times minus 1 over 3 minus 2. So this is, we can see that this is a negative value. This is negative, total negative. Hence, this is less than 0. Then, according to the theory we discussed, if double differentiation is less than 0, then what is this stationary point? So it is a maximum. Hence, x equal minus 1/3 is a maximum. Now, at x equal 1, d square y over dx square, this is x equal okay, we write at x equal minus 1. Then this is 6 times 1 minus 2, which is 4 minus 2, 4, or 6 minus 2, 4, which is greater than 0. So what do you know with double differentiation is greater than 0 with the discussion we discussed? It is a minimum. Hence, x1 equal is a minimum. So this point is a minimum. Question 3, y equal this one. So I'll explain minus 3x. Then dy by dx is 3x square minus 12x minus 3. So at stationary point, dy over dx equals 0. So 3x square minus 12x minus 3 equals 0. So x square minus 4x minus 1 equals 0. I think this is 4 times 2 times 4, not 12, 8. So then this is 8. So I can't do anything after that. So this is the one, 3x square minus 8x minus 3 equals 0. So I can break this one, 3x plus 1 and x minus 3 equals 0. X equal minus 1 over 3 or x equal 3. Now we'll find y value first. So we'll substitute here when x equal minus 1 over 3, y equal minus 1 over 3 cube, 4 times minus 1 over 3 square minus 3 times minus 1 over 3. So you will get, when you simplify, 14 over 27. So this is 14 over 27. And when x equal 3, y equal 3 cube, 4, 3 square minus 3 times 3. So this is going to be minus 18. So this point is going to be minus 18. Now I want to decide this point, those 2 points, what minimum, maximum or point of inflection. So I will delete this part and we'll work out. So y is, again, we'll check with the differentiation. Dy over dx equal 3x square minus 8x minus 3. We'll find the second derivative. So this is going to be 6x minus 8. Now we'll consider this point at x equal minus 1 over 3. D square y over dx square equals 6 times minus 1 over 3 minus 8. I think this is going to be negative, less than 0. Then second derivative is less than 0. Hence, this point is a maximum. Hence, x equal minus 1 over 3 is a maximum. Uh, at x equal 3, d square y over dx square equals 6 times 3 minus 8. So this is going to be 18 minus 8. This is greater than 0. Hence, double derivative is greater than 0. Then what you can tell about this point? Hence, x equal 3 is a minimum point. Not hence x equal minus 3 is a maximum, and minus 1 3 14 7 is a maximum point, is minimum, and 3 minus 18 is a minimum point. Minimum. Before I start this one, when the previous sum, when x equal minus 1 over 3, y is not 5 over 7, that has to be 1 5 over 27. I think please that is yeah, that's right, it is 14 over 27. Sorry, please disregard what I said. That's fine. It should be minus 1 over 3, this 14 over 7. This is y x plus x minus 1. So dy by dx is 1 plus minus 1 x minus 2, which is dy by dx is 1 minus 1 over x square. So at stationary point, dy by dx equals 0. It means 1 minus 1 square equal 0. It means x square equal 1, x equal plus or minus 1. Now we have two points. One is minus 1, other is plus 1. When x equal minus 1, so minus 1 plus 1 over minus 1. So this is going to be minus 2 when it equal minus 1. This is minus 1. 1 over minus 1 is minus 1 minus 2. And when it is 1, it is 2. When it is 1, 1 plus 1, 1 over 2, 2. So you have to find this one in the sum. Okay, I'll work out when x equal minus 1, y equal minus 1, then 1 over minus 1 make minus 2. When x equal 1, y plus 1 plus 1 over 1, 1 plus 1 is 2. Now we'll check the this is minimum maximum of the shape of this point. So dy by dx we found out 1 minus 1 over x square, which is 1 minus x minus 2. So then double derivative is 0 minus minus 2 x minus 3. This is going to be 2 over x cube. Now at x equal minus 1, d square over dx square equal 2 over minus 1 cube, which is minus 2 less than 0. Then what you can tell about this one? Then when x equal minus 1, the stationary point is minimum. Has to be maximum. If it is less than maximum. At x equal 1, d square dx square, this is 2 times 1 cube, this is 2, greater than 0. Uh, the stationary point is minimum. Question question E, I forgot to finalize. So that is so 1 2 point is a minimum point, and minus 1 minus 2 is a maximum point. Now dy by dx, we will write y equal x square plus 54 x minus 1 2x minus 54 x minus 2. So 2x minus 54 over x square. At stationary point, dy by dx equals 0. So 2x minus 52 over x square equals 0. So x cube equal 52 divided by 2, which is 27. This one y work out 2x equal 52 over x square. Then I bring x square, x cube over 52 and 2 down, which is 27. So now x value is 3. The third root is 3. Now we get the double differentiation. So d square y over dx square. So I have to differentiate one more time this one. Okay. 2x minus 54 x minus 2 d square y over dx square. This is 2 minus minus 2 54 x minus 3. 2 plus 108 x minus 3. 2 plus 108 over x 3. When x equal 3, d square y over d square equal 2 plus 108 over 3, which is greater than 0. Hence x equal 3 is a minimum. So hence x equal 3, we forgot to find the y value. So this is going to be 3 square 9, 54 over 3, this is 27, this part plus 9, that is 30, 54 divided by 3, not 27. So that is 18 plus 9, 27. So this is 27. So 327 is a minimum point. This is y equal x minus 3x half. So dy d over x is 1 minus 3 times half x minus half equal 1 minus 3 over 2 x half. At stationary point, dy by dx equals 0. So then hence 1 minus 3, 2x half equals 0. Minus, then 1 equal 3 over 2x half. So x half is 3 over 2. So we'll square both sides. Then x is 9 over 4. Now we have the point 9 over 4. Now we need to find y. When x equal 9 over 4, from here y equal x is 9 over 4 minus 3 times 9 over 4 half, which is 9 over 4 minus 3 times square root this one. So 3 and 2. So this is going to be 9 over 4, 9 over 2. So multiply by 2, then this is minus 9 over 2. So this is 4, so 9 over 4. So this point is 9 over 4 minus 9 over 4. Now we'll get the double differentiation. Dy dx equal 1 minus 3x 3 over 2 x minus half. So d square y over dx square is, this is become 0 minus 3 over 2 minus half times x minus 3 over 2. So this is become positive 3 over 4 over x over 3 over 4 times x minus 3 over 2, which is 3 over 4x 3 over 2. Now at x equal 9 over 4, d square y over dx square is 3 times 4, x is 9 over 4, 3 over 2, they all positive. We don't need to calculate to get the answer. We can, when you look at, we can see this is positive, hence everything is positive. Hence x equal 9 over 4 is the minimum. Hence 9 over 4 minus 9 over, it's a minimum point. So y equal, this is x half a times x, this is 3 over 2, this is 1.5 mean 3 over 2, and this is x half. And dy over dx is 3 over 2x half and 6, this is half x minus half. 3 over 2, this is square root x, and 6 divided by 2, 3 over square root x. So dy over dx. Now at stationary point, dy over dx equals 0. 6 divided by 2 is 3. X minus half I bring into a as a x half. X half is square root x. Now 3 over 2 square root x minus 3 over square equals 0. This means 3 over 2x square root x equals 3 square root x. I can see actually 3 to 3 cancel out here. 1 and 1. And this is going up, and square root 2x times equal half. So x is going to be um, x is going to be 2 plus 2 multiply. So this is x equal 2. We'll find the y value now. When x equal to y equal from here 2 to the power 3 over 2 minus 6 times 2 to the power half, which is I can write this is 1 times 2 half 1.5 minus 6 times 2 half. This is look like 2a minus 6a. What is the answer? 4a. Likewise, this is going to be minus 4 times square root x. I will tell. So this is minus 4 times square root x. This is not x actually, this is 2. So this is 2. Now we'll take the double differentiation from here. Dy over dx equal 3 over 2 x half minus 3 times x minus half. So d square over dx square, d square y over dx x square, 3 over 2 half times x minus half. This is minus 3 times minus half x minus 3 over 2. So this is 3 over 4 over square root x. This is plus 3 over 2 over x 3 over 2. I can see that all are positive. Then if x is positive, this answer is going to be positive. When x equal to dy over dx square 3 over 4 square root 2 over 2 times 2 3 over 2 greater than 0. I don't need to look at it. There is no negative terms here, and this one x equal to positive, then answer definitely should be positive. Hence when hence x equal to is a minimum. Hence 2 minus 4 square root 2 is a minimum point. I will take the dy over dx, that is 4x cubed 24x, and at the stationary point dy dx equals 0. Then 4x cubed minus 24x equals 0. You take, so this is 4x square minus, I can take 4 out as well, x square minus 6 equals 0. So then I can write like this as well. If I divide, okay, 4x, this is x square minus square root 6x square. So x minus square root x plus square root x equals 0. So then x equals 0, you can divide by 4. When you divide by 4, x minus square root x plus the square root x equals 0. So x equals 0 or x equals square root 6 or x equal minus square root 6. There are three points. This one also you can work like this. 4x times x square minus square root 6 equals 0. So then x equals x square minus 6 equals 0 divided by x equals 0 or x square equals 6. It means x equals plus or minus square root 6. So then x equals 0, x equals minus and x equals plus. So you can work out like that as well. Now we have 3 points. So we'll find the relevant y coordinates now. X equals 0. What is this one? It is easy. Y equals 0 for minus 12. 0 for is 0. Then x equals minus square root 6. What is the y? So y equals square root 6 4 minus 12 square root 6 square. So this is going to be 36. And because square root 6 square 4 mean you can write square root 6 square times square root 6 square. This is 6 and this is 6. Square root square mean 6. So this is 36 minus 12 times this is 6. So 36 minus so minus 36. So now this is minus 36. Right now, when square root 6, what is the answer? So in that case, still the same answer because this is minus square become positive because since this is even powers, it doesn't matter whichever number, you will get the same answer. So you can work out and show. Right. So now we know the 3 points. My argument here was, now assume x4. It doesn't matter for this one. If we want to assume x equal minus 2, is still the answer is same. X equal 2 is still the same positive answer. It doesn't matter because this is a even number. That's why I explained here. That's what I explained here. Now we'll get the double differentiation. D square over dy x square of this one. So 3 times 4, 12x square. This is minus 24. Now at x equals 0, d square over dx square, 0 minus 24 less than 0, that is maximum. So 0, 0 is a maximum point. 0, 0 is a maximum point. Now when x equal minus square root 6 or x equal square root 6, can you see that d square y over dx square equal minus Oh, plus, I'll write both square. It doesn't matter because this is positive. Even 12 times minus 24. So this is going to be 12 times 6, 72 minus 24. So this is greater than 0. Hence, when x equal minus square root 6 and x equals square root 6 are maximum. Hence, minus square root 6 minus 36 and square root 6 36 minus 36 are maximum. Minimum. Greater than 0 mean minimum. So minimum point.